Hello and welcome to my video. It's a pleasure for me to see you here and what we want to talk about today. So first of all, we want to have a look at DevOps and DevSecOps, and then we want to have a look at SRE, Site Reliability Engineering, and how they're implementing, or what is the potential of implementing security with this approach. Can we merge both approaches, this DevOps and SRE? And if we are merging them, what is a good point to start, or what is a potential we can get out of this merge of these two different strategies? So if you're interested in this, then you're right here. By the way, my name is Sven. I'm developer advocate for JFrog, and as you can see, I'm right now in the forest. So I'm hiking since 2 days and spent the night in the woods, and the last day it was just raining. So I decided to start with my recordings today, and there's a little bit sunlight, and I hope it will be better today. So then we will start. I will take you on two journeys. One is the DevOps SRE journey, and the other one is here a little bit through the woods. Okay, let's start with the topic. And the first thing I want to just have a short recap is about the term DevOps. DevOps was this merge of Dev and Ops, and it was first mentioned 2009, 2010, something like this on Wikipedia. And if you're looking at this topic, you will see that DevOps itself is a description of different steps of the software development. It means you start with coding, testing, building, and so on until it's configured and running in production. And then you start again from scratch. We have different things I want to highlight here, but first of all, have in mind that DevOps is focusing on a process. It's focusing on this developing stages from I start coding an application until it's running, and then we are cycling. So this is more or less a basic idea of DevOps. So the dev team and the ops team are merging so that you have a little bit more experience with ops, and at the same time as an ops you have a little bit more experience of dev, and everything is running hand in hand so that you have this smooth transition between coding, building, testing until it's running in production. And if something's going bad, then you start again, fixing it, and it's running again. So that's the basic idea of DevOps. I think the most of you will just know it, but there is a slightly different thing between 2009 and now. What the big change or the difference between 2009 and now? Well, the biggest change, I think, is in the way how you can virtualize this environment. So 2009, 2010, you had these desktops, and laptop was not strong enough to hold the whole pipeline on your environment, or the whole environment on your laptop. And now it's completely the opposite. So you can have the full CI pipeline you can have still on your laptop, on a regular laptop. So this is something that really dramatically changed the behavior of DevOps. So it's really easy now with low budget hardware to have the whole tech stack running on a laptop. And this abstraction layers with virtualization and this clustering and all this stuff, even this is, possible on laptops now. So this is a big change. So the DevOps term switched slightly following this technical improvements, and it was faster and faster. This iteration cycle was faster and faster because you could do everything or more on your laptop and not waiting until it's done on a heavy CI environment that's somewhere in your infrastructure. So having in mind that this change over the time, but in general we have always the same. We're doing something, we're testing it, we're running it, we have the same environments, the same database, and the same whatever thing running, so that you really can play with the same technology that is running in production. Okay, having in mind that this DevOps terms came from 2009, 2010, something around this years, the same happened with Google. So Google appeared around these dates as well and started growing and scaling. And they had this need for this reliable services, and they had this vision that everything must be automated as much as possible. And this was completely new idea during this stages or during these years in the beginning of Google, and they reinvented all this way to handle massive infrastructure. And from this they invented their own view of some kind of DevOps. They didn't call it DevOps, they called it SRE, so Site Reliable Engineer. And what's a Site Reliable Engineer? So this is a person that is responsible for some coding stuff as well of some improvements in the operations. And this is more or less DevOps in one person. But what's the theoretical definition of it? Okay, they reinvented or they implemented their own version of DevOps because there was a need for it inside the company, and they defined some rules. And the rules of a site reliable engineer is that this person is 50% focusing on ops. It means on how to improve, automate things, but the max part of his time is 50%. The rest, so 50% or more, this person is a developer. So it means that he or she has to implement stuff, so use cases or implement tools that help to automate stuff and so on. So this is more or less a basic definition. There is no bigger part than 50% of ops, because they want to make sure that everybody is not only spending on optimization, so it's spending time on improvements as well in terms of creating new tools, implementing use cases, not losing the context to the dev world. So this is one thing. And the other thing is they have a very interesting approach of dealing with downtime. Google was ahead of the time. During this time, they defined the term failure budget. I remember it quite well. So during the time at 2009, 10 and so on, working as a software engineer, it was mostly there is no bugs, everything must be perfect. And this was just, well, far away from reality. So we have bugs and some things are going wrong. And Google was really innovative in a way that they called it normal. So everything will have some bugs, everything will have a failure. It's just a question of time and how much, and if you're dealing with this failure in the right way. And they want to improve the availability of their services. So they created this term called failure budget, and an SRE is able to spend failure budgets. What's a failure budget? A failure budget is some time the system could be down. So and this is a certain amount of time they define. So this service for 3 months has a downtime of whatever, a failure budget. And it's not only a service level agreement like, oh, the maximum downtime that is allowed, blah, blah, blah. No, it's really like, okay, you have 3 hours, for example, and the 3 hours you can invest. And this is really something new. So you are able to invest downtime to improve the system. And this is like a budget. So who's consuming from this budget? Hardware failures, software failures, cyber attacks, whatever, but updates, improvements, reorganizations as well. So they had the possibility to invest time to improve the system, and the whole downtime was just measured. It was not something different to improve, and the other thing, it's failure. It's just a certain amount of time, and this is a failure budget, and an SRE is able to invest with this failure budget to improve the stability or the availability of this service. Okay, talking about the DevOps and the SRE approach, they have some similar points. So they want to improve the development cycle, they want to improve the availability, the handling of bugs and all this stuff. But they have this different approach of DevOps is a process. So it's really from coding, building, testing, packaging, and so on, up to running in production, and then again. And this is describing a team, a DevOps team. And the SRE is not a process, it's just a person. What means just, but it's a person, it's not a team, and it's not a process. So it's a behavior, it's dividing time, available time, into different things like ops and dev. So that this both worlds fits together, I personally think yes, it fits perfectly together, because if you're looking at this DevOps environment, you have this more dev people, you have this more ops people, and just a tiny amount of persons in this environment are really nearby half and half. Half ops, half dev. So it's a very senior developer that is focusing on ops, on very ops-centric person that is now focusing more on dev or whatever. But this half and half, this 50-50 split is not so often really present in some people. So most people has favor for dev or favor for ops and doing the other stuff as well. So does it fit together? Yes, the process itself is a process description perfectly, because you have all these development stages. And then in the middle, so the glue between the dev and the ops is exactly done by this SRE, or by persons that are focusing like 50-50 on both sides. And what is the good thing here to have it? Well, you can focus here if you are this person in the middle, exactly between dev and ops, and you're dealing with both sides half and half. You have the possibility to merge both strategies, more from the dev side or more from the ops side, together, so that there is no semantic break in between. Most people try to do it, so the whole DevOps environment try to break this barrier between. But mostly you have people more dev, more ops, and then they have some kind of handover, some kind of specialization. But the SRE is a dedicated person. So if you have this DevOps environment, then this dedicated SRE in the middle, with the possibility to spend failure budget, then you have a very powerful construction or mechanism to improve the whole DevOps environment or the whole SRE approach, because you are not only talking about a process or a person, but you are making one good thing, one big thing out of it. So my personal opinion is, does an SRE approach fits to the DevOps world? Perfectly. Makes it sense to have a dedicated SRE engineer, or this SR engineer? Yes, because he has a dedicated role, and this person should focus not only on different stages of the DevOps environment. This person should focus on this topic that are over all stages, like quality, or like, for example, security. Okay, let's talk a little bit about the cross-cutting topic security, because then we can see how the DevOps and the SRE approach are helping each other to fight against vulnerabilities or attacks. And one attack that was very prominent and changed a lot of stuff in the world is the Solarwinds attack. But who's Solarwinds? Well, Solarwinds is a company that's building software that's managing network infrastructure, and this software needs very high rights, because then it's able to manage this network infrastructure. And this tool is not so cheap, means that just bigger companies with huge networks and a lot of networks are using this tool, and this is done by approximately 300,000 companies. That's a lot of stuff. But what happened? What happened at the Solarwinds company? So the Solarwinds, they have the CI pipeline internally for their software development for the product called Orion. This is this software to manage this network infrastructure. And the hacker group just broke in. They not destroyed anything. They didn't steal data, compromise things, nothing. They just focus on the CI environment. And the CI environment was building the binaries for this Orion platform. So it means the software product. And they manipulated the CI environment in a way that with every new build, the binary that was created was including some compromised binary, so that the final result of the CI environment was a compromised binary already. And then what happened? Well, they created a new version. This version was compromised. This compromised version was delivered via automatic updates worldwide. Fantastic. Having in mind that 300,000 potential targets are addressed with this single hack, this is a huge multiplication. And having in mind that this software is not so cheap, and you need only software to manage network infrastructure, if you have a huge amount of network infrastructure, means that all customers are more or less dealing not only with a single server, they are dealing with a complex infrastructure. So every compromised target is not a single dedicated server, it is a compromised network, a complete compromised network. And well, we had targets like US governments, military, space, defense, pharmaceutical, automotive, health, insurance, whatever. So everywhere worldwide we had in a few, I think, days or a week, approximately 50,000 attacks. So positive attacks, not just to try to attack. It was really compromised networks. And this is a huge number, 15,000 compromised networks in just one update stream. The really bad thing with the Solarwinds attack is not only that it's going against the supply chain, it was tricky because after these compromise updates were delivered to the customers and the customers were using this binary, the compromised binary was doing nothing for 1 or 2 weeks, and then it started checking around what's going on in this network and started downloading additional binaries. So every Solarwinds infection is completely different to other infections. Means you don't have just this single thing you have to do to get rid of Solarwinds. Now you have really to shut down the whole network infrastructure, more or less start from scratch again. And this was really, really biting a few people. And so we got some reactions. And one reaction was the executive order of cybersecurity from Mr. Biden for all non-US citizens. I'm not a US citizen, so I had no clue about an executive order. What does it mean? The executive order means that the US president can, with this executive order, not change law or change tax rules or whatever, but he can change the way the US government is working internally. Like a CEO of a company, he can define the process, the way of operations. And the basic idea of this executive order of cybersecurity is that every binary that is used by US governments, directly or indirectly, must have this SBOM, this software bills of materials, so a complete list of all ingredients that are used to build this binary. So the Solarwinds hack was not only influencing a lot of networks and damaging a lot of stuff, but it's changing even the rule how the US government working with IT. And this is a big thing. Main question is now, is security part of the SRE role? And would it be possible to fight against something like the Solarwinds hack? What should have we done to be prepared for the next Solarwinds thing? So first of all, I think the SRE role is a very good position to implement this topic security, because if you have an SRE and the SRE is not so deep in domain-specific things, but more in these broad topics like quality and especially security, he is able to have a coherent strategy of all these different techniques we have in the field of security. I want to highlight the 4 main groups about security, and then we will discuss what we should focus in which order and how to start with all this stuff. What are the 4 main topics I want to highlight that is working in the field of security, or what are the main techniques? So we have ZAST, DUST, EAST and RASP, and I want to go through them step by step so that you can identify what is what. The first thing is ZAST, Static Application Security Testing. So it's a quite old technique. So you're scanning all binaries or all components that are part of your whole tech stack, and then you can identify known vulnerabilities. So that is the main thing. So you're fighting against known vulnerabilities with this. We have the approach that in the static approach we are searching for unknown vulnerabilities as well. So it means that we are looking at source code and try to identify if there is some pattern recognized in a way that it could be compromised from outside later. The challenge here is that mostly you don't have this dynamic context of this piece of code that you're analyzing, and all the machine learning and AI-based stuff it's a good approach. It's still under development. It will be very powerful in the future, but right now it's not so. We are not at the stage we needed to have. So mostly if you're talking about ZAST, Static Application Security Testing, it means scanning every component in a static environment, so without the dynamic context, and try to identify known vulnerabilities, you have something, or unknown vulnerabilities if you're analyzing source code. And that's the third approach about scanning binaries. It's try to identify malware, and if you think about how developers working, it is mostly in a way that you're grabbing pieces of code. The famous example is Stack Overflow. So you're just searching for something, copy pasting it. But to say the truth, the developer of this randomware or malware or whatever ware is more or less doing the same. So they have basic things or bricks they're using to put together and then creating new things. So there is another approach that is focusing on identifying new vulnerabilities in terms of identifying binaries that are used in some other vulnerabilities or malware or whatever, ransomware already, and try to identify what's going on here. So, but everything is focusing on the static application security testing, so the static context. The opposite of this is dynamic application security testing. Okay, now coming to the Dust part, the dynamic application security testing. So it's the opposite of Dust. So Dust is scanning all components, and Dust is not scanning all components. It's just looking from outside at your running application. Means you can start with Dust first time if you have something that's able to run already. So it's later in production stage or even in the production itself, so if it is running on production. So it means Dust is try to identify what is a way to attack your system or to compromise your system. So it's a hacker approach, and it's based on the most common vulnerabilities, so like SQL injection or buffer overflow and something like this. So you have no knowledge about what's internally used, how many components you have, what's the technology you're using, and so on. And mostly Dust is working against remote accessible systems. So Dust is mostly not used against a desktop app. It's mostly used against web apps or mobile apps or whatever. So the good and the bad thing of this Dust is, so first of all, yes, you can identify unknown vulnerabilities if they are based on most common vulnerabilities or these attack vectors from the most common vulnerabilities. On the other side, running a Dust scenario against your application is something very time consuming, because you need a huge amount of different attack vectors. You're going through the full permutation is quite a huge amount of steps. And it makes only sense if the system that you are testing or that you are with Dust is nearly like production, because you can identify dynamic context. Dynamic context is based on configuration and so on. Means if you have a misconfigured system, open ports or whatever, you can identify it with Dust. Mostly you are not able to identify it with Dust. So you have more control about the dynamic context of the application. On the other side, you have to make sure that if there is a new attack vector, your Dust tool is updated, because otherwise you're not able to identify this new approach. So, and this is one of the weak points. Mostly these Dust tools are tools that are running in the clouds to have enough CPU power and enough bandwidth to attack your system. By the way, your system must be able to survive if you're attacking it with Dust. So it's, don't do it if your production system is just falling apart, so if the Dust attack is coming. But more or less, it's time consuming. It's mostly tools that are not easy to customize, because it's a software as a service thing, or it's a complex tool that you need to understand how to define attack vectors. So mostly Dust tools is based on the most common vulnerabilities. There are some fuzzy logic that are playing around with some different approaches. This is usable by a regular developer, but if you want to customize it, then you need very deep knowledge. And if you have now Dust and Dust, the next logical step is that we are doing it together. So, and this is called IS, Interactive Application Security Testing. Interactive application security testing is a mixture of Dust and Dust, so static application security testing and dynamic application security testing. plus an interactive part. So what does it mean? So you are scanning all components against known vulnerabilities in a static context. Perfect. Then you try to identify with the dust parts the dynamic behavior of this application. And then you have this component of interactive. It means that you as a developer must be able to attack the system manually. So you have this tool stack, and then you defining attack vectors and interactively checking what's going on inside the application and attacking at the same time the system. So it's more or less a security debugging. So it's, yeah, you could see it like security debugging. So you have full access to all the components on the static side, on the dynamic side, and you are doing this attack step by step by yourself. That means that you need a very good knowledge about the attack vectors, and you need a good knowledge about the tooling, how to do these attacks. And to say the truth, mostly IAST, yes, it's a logical follow-up step of thus and thus, but mostly it's in a way that you need very specialized people or very high-skilled trained people to do this. Otherwise, it's useless, because this interactive security approach or this interactive attack must be done with the knowledge about the domain-specific things, about the technology you're using, and the knowledge about how to attack exactly against these technologies. Yes, so for this you need really dedicated people that know what they are doing. Otherwise, it's just fishing in the dark for something, but it's not really a reproducible. This is a very difficult word for me. Reproducible. Forget it. You know what I mean. So you can't do it every time with the same amount of quality and speed and so on. So it must be in a way that everybody is able to do, to analyze it, to understand it, and so on. So IAST, yes, is an evolution of thus and thus, but mostly you need very specific knowledge to be efficient in this. And then we have the fourth thing that's called RASP. The fourth group I want to highlight is RASP, runtime application security protection. So, and you hear it with the word, it's not testing, it's protection in the end. So it means with RASP, you're not identifying known vulnerabilities or whatever. With RASP, you're identifying an actually ongoing attack, an ongoing cyber attack against your system. So RASP is nothing you can do previous production. You can just do it in production. So you really can monitor your system and then what's going on. So how this is working in a bird's view. So you have this agent approach, and this agent is manipulating a little bit your software in terms of analyzing. It's like an APM tool, like application performance measuring thing. It's adding bytecode or adding instructions to identify what's going on in the system and try to identify if there is some behavior or some usage of this application that is not correct. So they're using machine learning, pattern matching, and all these different fancy technologies to identify what's going on in the system and if this is something good or bad. The good thing is they are very good in identifying these attacks, and then we have two possible reactions. One possible reaction is just monitoring and alerting, so someone else has to do something, and the self-healing process here is, or the self-defense process is, if you're activating the automatic shutdown. So if there's a component, a microservice that's actually attacked, then this source code or this tool can decide, okay, now it's time to deactivate it and to shut it down or isolate it or whatever. So RASP, yes, is a very good tool, but the disadvantage of this one is that if you're just using RASP, you can just focusing on runtime inside production. In some environments, it's not allowed to use this agent approach to manipulate this running software. Having in mind that even the agent could be compromised, this would be a disaster. But on the other side, it's far too late inside the production pipeline. So you have a lot of time before, and then just focusing on the runtime, it isn't really the best approach. So now coming to what should you focus first, or what is the order you can start with? And this I want to highlight in a few seconds. After having a better view on all these 4 topics, the question is, what should you focus first? And back to the topic SRE, why an SRE, or what's the best place for this DevOps environment with an SRE implemented to start with? So all this I want to highlight in some kind of conclusion about this subpart here. RASP is this runtime application security protection. This is very late. It's just in production. And if you want to start with security, then this is more or less one of the last steps you should do, because this is just the last border or the last wall of defense. You have so many other choices that are easier, faster and cheaper to do before you start working with RASP. And mostly if you have just RASP developers and all the other people inside the organization, they don't care about security because this RASP tool is doing everything, because there's natural attack, compromising or defending and so on. So this makes no sense to start with this one. This is a perfect approach if you have previous things done, but it shouldn't be the first. The next thing I want to highlight is this IS part. So IS, yes, it's static, it's dynamic, so it's merging both worlds, but the interactive part is mostly only good if you have already people that are deep in this topic. And if you want to start with security, mostly you don't have access to a person that is so deep in this, so that he can really actually doing it, and learning this stuff is not so fast and easy done, so it will take some time. So it makes sense to focus on the other parts, so this SAST and DAST part. Why? It makes sense because you can use tools and knowledge, and then you can start learning about the security topic itself, and then it depends a little bit on your infrastructure. So if you want to do the DAST part, have in mind that's very CPU and runtime intensive. It's first possible if something is already running and it's focusing on most common vulnerabilities. So you have this fixed amount of attack vectors. On the other side, if you're focusing on SAST, and this is my personal recommendation for you, if you start with security, focus on SAST, because then it's the only thing that will give you the possibility to scan the whole system, really every single component, and it's focusing on known vulnerabilities, and this is by far the biggest part if I'm reading all the different resources right, compared to unknown vulnerabilities. And the known vulnerabilities is an amount that is constantly growing, and there is some kind of unknown vulnerabilities, and if I'm getting it right from different resources, it's more or less the amount of known vulnerabilities is bigger than the amount of unknown vulnerabilities and constantly growing. So this means if you want to start with security, focusing on static application security testing inside every stage, and then this dynamic application security testing to protect the behavior, the dynamic context, and then later you can do something like IST or RASP and so on. That is first the 4 parts of security. And now the question, why an SRE is a perfect match here. So having in mind that you have this dev part and the ops part. If you're looking at SAST and DAST, what I'm recommending focusing first is that SAST is done inside the dev part mostly, and DAST part is mostly done in the ops part. So you have the different approaches. And if you have someone who's really in the middle and focusing on all this big topic that are not dedicated to one step, like an SRE focusing on security, then he's able to merge all the strategies to make one aligned strategy out of it, because he is in the middle. He is exactly the border between dev and ops. So make it sense to have some SRE for this security topic inside your DevOps environment. Perfectly. It really perfectly matches. So, yes, the SRE, from my point of view, is a perfect place to start with quality, security, performance, and all this stuff. We heard so many things about security, SAST, DAST, IS, RASP. My personal recommendation is focus on SAST first, and if you want to try it out, well, surprise, surprise, you can come to one of my free workshops, register at JFrog, and then you can do the first steps with me together with the JFrog tooling about SAS, so static application security testing, because then we are scanning all the binaries. I will show you how to do it over technology borders and so on and so on. So it's for free. And if you want to try it out by yourself, just go to the free tier, register and try JFrog X-Ray. So that's a term you should search for. But if you have any more questions, then feel free to contact me. So on Twitter, LinkedIn. If you like this outdoor style, have a look at my YouTube channels. I really would appreciate if you're my new subscriber. I have there a lot of Java and security and DevSecOps talks in the woods. So you can see where I'm running around. And wow, perfect. No rain. So I really appreciate this one because yesterday it was just raining and early morning this day it was really raining. So I'm so happy that I'm dry again. Okay, so far so good. What I'm doing now, I will now search for my car. I think it's something like an hour or two in this direction if I'm right, but I have to check it. With my GPS in a few seconds, and then I'm walking home, cutting all these pieces together. I hope you enjoyed this video. If you like it, give me a thumbs up and give me some cool feedback. If you have any ideas what I should talk about next, just mention it, ping me on Twitter, LinkedIn and so on. Give me some feedback about this one. So thank you for attending. It was really a pleasure to have you here. I hope you enjoyed not only the topic, the words as well. And then whatever time you're seeing this, enjoy it, stay safe, and see you.